Hi guys, and welcome to Journey Through to the Centre of the Earth. This is activity 2A, which is going to be looking at weathering for year 8s. Okay, so what is weathering? Well, there are two processes that are involved in this. There's weathering and erosion, and they're going to be looked at in individual units. And this is the reason, or the main process, whereby rock is broken down. Now, in order to study, we're studying this first, is because that's one of the three types of rocks is caused due to this process of weathering and erosion. So the question is, what is weathering in this case? Now, weathering is the process whereby obviously the weather is used to actually break down the rock. Now, there are two types of weathering. There's physical weathering and there's chemical weathering. So in physical weathering, what we've got is there is no change to the actual minerals which occur. The minerals just remain within the rock, and as a result, by the process of the environment, they are broken down. Now you can see, and you look at these tombstones. These tombstones here have undergone the process of weathering. Now basically what you found is the top one is nice and clean, and you can see the bottom one has been broken down with time. Now the main processes that can occur with weathering are the processes of expansion and contraction. Now this is quite interesting, especially when you look at rocks, because as rocks get further down in the Earth's crust, they get subjected to heat and pressure. Now when you heat something up, the chances are, or the minerals, the chemicals inside it begin to expand. So there's your process of expansion due to the heat. And if you cool something down very quickly, and this can happen in the oceans or it can happen in places like the desert at night time, they can contract. And this whole process of expanding and contracting can be one of the major causes of weathering of rocks. Okay, so how does it work? Well, let's take a situation like we've got here. In diagram 1, what you can see is we've got two rocks together, and there's a crack that's formed in between the two rocks. Now, during the day or after a rainfall, those cracks can fill up with water, and if the conditions are right, especially at night time, what will happen is that with respect to water, when water freezes, we know it expands. Now, and this is in some case contradicts what we've already said, but this expansion, you can see if you put a plastic bottle in the freezer, you fill it up with water, put it in the freezer, and wait overnight, and you'll find that the bottle is cracked the following day, and this is because it's expanded. Now what happens is, in somewhere like a desert, the water expands, and as it expands, it pushes apart the rock, only very slightly, and it forms a new crack. Now you can see in diagram 3, the black line at the bottom is showing the new crack. This is due to the expansion of that water, which is frozen. Now, because it's expanded, the new crack forms. When the day starts again, basically the water melts and disappears, but the rock is now left with a new crack. Now this crack may be minute, but you think about this process happening again and again and again over millions of years, and the result is you're going to get a bigger crack, and eventually fill up with water, expands, a little bit more of a crack, and so forth and so on, and eventually the whole thing is going to split apart. Now as a result, this is some ways how mountains turn from big mountains into larger boulders, and then the larger boulders may change into rocks, and eventually those rocks can be split apart into pebbles, which are able to be transported from one place to the next. So you get the idea that we get a crack, fills with water, it expands. The expansion causes a small crack or fracture in the rock, the water melts away, and then the whole process recycles millions and millions of times until eventually we get a huge crack. Now look at these Devil's Marbles, which are in the Northern Territory of Australia, and you can see that they've been sheared in half. Now no one's come along and smashed them. These are the size of a grown man. So what's happened is that process has occurred, and you can see the crack, and the water has just got into those cracks and split it apart over millions and millions of years. Here we've got situations where we've had weathering of these rocks, and they just seem to be standing there on their own. This is because water has got into the rocks around it and just left these boulders surrounding. This is the Breadknife in the Warrumbungles National Park in New South Wales. And again, what's happened is water has got into soft rock and broken away, and the hard rock is left left standing. Okay, so there are other types of weathering that can occur. These include, for example, lightning. You get any lightning, that's going to split the rock, huge amounts of energy, comes down from the sky, hits at the earth, and if you've ever seen a tree hit by lightning, you'll know the type of energy that we've got. Well, that's going to work just as equally on rocks. Also, roots. How often have you seen a tree root in a pavement that's actually broken up the concrete? Now, this uses the concept of water expansion. The root is able to go through fine little cracks, and then it fills up with water. As it fills up with water, it's under huge pressure, and that pressure forces the rock out, and then it moves on into the next bit and then forces it out. And the result is it's like having a jackhammer or a jack that you've got underneath a car pushing open the rock. So you can see here that the roots have got into the crack and they've pulled apart just by the process of water. See the roots down on the bottom in the pavement? Same sort of thing. There's a little crack, get a little bit of mud in there, in goes the seed, and it starts growing, and it's that whole process of water actually expanding the rock. Chemical reactions basically work in another process. Now, in this case, what happens with chemical reactions is that you actually get a change in the actual mineral that's formed, and this is often due to a mixing of water and the air. Now, for example, limestone. Limestone is basically made for creatures. It's quite soft, so this can be worn away very, very easily just by chemical weathering. Now, if we go back to the limestone tombstones that we had at the beginning of the presentation, you can see how one got worn away with time by the process of water and air together. Now, you put water and air together, especially in areas where you've got large carbon dioxide contents. What you can have is water and carbon dioxide can combine together to form a very mild acid called carbonic acid. That acid will then eat away at the rock and actually start breaking down the chemicals which are inside the rock. And the result is, over millions and millions of years, you can produce channels and caverns. Now, you can see here we got the Jonaland caves in Western Sydney, and obviously the Grand Canyon is probably one of the greatest features on this planet, where you can see where weathering and this sort of breakdown over millions and millions of years has produced this fantastic landscape. Okay, so that basically finishes everything that we've done on weathering. Join me again and we'll find out about erosion.